Hi, I'm Katie, and this is lab number 1, Accuracy and Precision. The purpose of this lab is to show the difference between accuracy and precision and what that means. So this is my target where I will be throwing my projectiles. I have 3 projectiles, each is a piece of paper that was the same size and length and whatnot, and I just crumpled them up. So I have my 3 projectiles. I'm going to be throwing from this X here. So I'll be throwing each of my projectiles from the same spot. All right, so I have my first projectile. Let's see where I hit it. All right, that one was not that accurate, meaning that I didn't really hit the target. I'm kind of close, not too bad. Let's see my second throw here. Okay, also not accurate. I did not hit the X, but let's see this third one where it falls. All right, so I have 3 projectiles that none of them hit the target, so I definitely wasn't accurate. Let's see how they measure away from my target, what their actual measurements are. So I'm going to take my ruler here and measure from my bullseye target here, from the center to each of my projectiles. All right, so this one goes 11 inches. So projectile 1, 11 inches. Now projectile 2, same thing, measure from the bullseye. So we have 12. Plus 2, 14 inches from the bullseye. So projectile 2 is 14 inches from the bullseye. And then we have projectile 3. So from the center, 12. Plus 5, 17 inches. All right, so we have 11 inches, 14 inches, and 17 inches from the bullseye, respectively. And so we're going to label my bullseye now. Klingensmith, accuracy and precision. 818, 20. So that's my target. Take a picture. I'm going to use a piece of string to find the smallest circle that will enclose the final position of all 3 projectiles. All right, so here's my string that I'm going to use to enclose, so we can kind of get them in a group. Why we would want to have them all inside the circle is this is showing how precise I actually was in throwing my projectiles. So the closer that my projectiles are to one another, the more precise I am. The further away, the less precise. So if you put them all in a circle, that allows me to group them and actually measure the distance from one to the next and understand how precise I was, even if I may have not been that accurate. All right. So I'm going to place the string around the projectiles. Measure and record the diameter of this circle in inches. it's definitely not the center of the bullseye. Alright, so a circle that encompasses everything for the most part. So the diameter, the width of the circle. So we have 12 plus 7, 19. So 19 inches diameter. At this point, we're measuring the precision, not the accuracy. The accuracy is where the projectiles are in relation to my bullseye. So here, when I was just measuring in the diameter of my circle, I was actually looking at how far apart each of my projectiles ended up being. So the closer they are together, the more precise I was in my tossing of the projectiles, and the further apart, the less precise. The closer they are to the target, the more accurate I was, and the further away, the less accurate. You can be neither precise and neither accurate if they were all over the place, but I'm more precise in that they all kind of grouped in a similar spot, however, not that accurate. But the actual measurements will show what my accuracy was and what my precision is. So I have two people that are going to be doing the same experiment that I did, and I'll be measuring their accuracy and precision. They'll be using the same bullseye that I did, this X here on the table, and they'll be tossing from that same X that has been marked on the floor. So we have both Nick and Bob doing this experiment as well with me. And I hypothesize that Nick will be better than Bob at throwing the projectiles. He will be more precise and more accurate in his throws. All right, let's find out. All right, so first we're going to measure his accuracy. How close was he actually to the X bullseye? So his first projectile is 11 inches from the center. So number 1, 11 inches. Second projectile, $12 inches. Third projectile, $14. All right. Diameter. So I'm going to use this string to construct a circle around these projectiles and measure the diameter. Okay. So the diameter of this circle is 9 inches. All right. So now we're going to test Bob. We'll see if my hypothesis is correct, that Nick is actually both more accurate and precise in his throws. We'll find out. So I'm going to clear the table. Same projectiles used, same bullseye, same spot. And here we have Bob. Okay, so let's see how Bob did. First, same thing, we're going to measure from the point of the bullseye, the center, to the projectiles. So first projectile is 8 inches. 6 inches. And third projectile is exactly 12. 12 inches. Alright, now let's get the diameter, which will show how precise these throws were. Twelve inches in diameter. Alright, pretty close. Alright, so we'll see if our hypotheses were correct in our table. So thank you for joining me with this experiment, and this was demonstrating accuracy and precision. Accuracy meaning how close the projectiles were to the actual target, and precision meaning the distance between the projectiles. So the closer the distance between the projectiles, each of those 3 respectively, the more precise your measurements will be, the more precise you are. And the further away those same projectiles are, the less precise. So this is demonstrating what precision versus accuracy means. All right, this is part 2 of Lab 1, Accuracy and Precision. For this experiment, I have 2 20-ounce bottles filled with water. As you can see, I just have tap water in here from my kitchen sink. Each are equally filled. And I'm going to place these bottles on this kitchen scale here to find their measurement in pounds. Alright, so these measure to be 3 pounds and 14 ounces. So we're going to take 3 pounds 14 ounces as my measured weight. 3.14. And the accepted weight for 2 20-ounce bottles of water is 2.608. So in this, I actually did kind of expect there to be a percentage of error in the experiment because it didn't really specify what type of bottles I'm using. So we're also measuring the weight of these bottles. So that's included in the weight of the water. My measurement was slightly off. It weighed a bit more than the accepted value for 2 bottles. I'll be doing the measured value minus the accepted value divided by the accepted value times 100% to get my percentage of error here. And like I said, I did expect this to happen prior to the beginning of part 2 of the lab, just because there's a lot of variables here. So with the variable number 1 is my kitchen scale. My kitchen scale might be slightly different than someone else's, or someone using a different type of scale altogether. Another variable here is the bottles being used. So it could be a plastic bottle, it could be glass. Here I have a Hydro Flask, which is totally different than both of those. It wasn't specified what type to use, just fill 20 ounces of water in bottles. And here we go, we have 2 bottles of water, 20 ounces measurement. All right, and that's it. I will be presenting the percentage error in the table 2 for my part 2 of this experiment. Thank you.